Algebra 1 lesson on Unit 3 Linear Function Equations and Inequalities, Module 5 Linear Functions, Lesson 5.1 Understanding Linear Functions. Okay, guys. So this is what we begin with. We are exploring the idea in a classroom situation. This will be a group work, right? But if you'd like to mimic that, why don't you go ahead and read this first, and you may pause the video. Okay, guys, in this particular scenario, we're talking about a race car that could travel like 210 miles per hour, right? So if it were to travel continuously at this speed, we would have the equation y equal to 210x, x being the number of hours and y being the miles that it travels, right? And solutions are graphed over here. Now remember, it says continuously, but we only graph some of them to indicate the way the line should be, and we would connect them straight like this way because the keyword over here was continuously, right? And the graph the car speed is a function, right? The keyword here is a function. Let's underline that, shall we? Because for every x value, it is paired with exactly one y value, right? And because the graph is also non-vertical straight line, it is also a linear function. That is to say that this is a function that forms a line. Okay. It may seem kind of obvious, but it needed to be said. So how do we come up with this over here, aside from just reading the situation? Okay. So what we can do is put all those data points, guys, right, into the table over here, and that would be ours will be 1, 2, 3, 4, 5, and the it will be 210, 420, 630, 840, and 1050. Now part B is asking you, using the table, check that x has a constant change between consecutive terms. So that over there is in x term, we're continually adding 1. Have you noticed that? So you could do it the way I did it, or if you want to do it on a to show the calculation, what you can do is like 2 minus 1 is 1, 3 minus 2 is 1, 4 minus 3 is 1. We are basically taking the term, subtracting by the previous term this way, right? And then 5 minus 4 is 1, and they're all constant. Okay? Good. All right, so now it's asking, check that y has a constant change. Okay? Similarly, you could go like 1050 minus 840. What does that equal to? 210. And then the 840 term before that was 630, right? When you subtract it, you get 210. 630 minus 420, that's also 210. And 420 minus 210 is 210. So we show that they were constant. Great. Another way to do that is quickly, you realize you're adding, oopsie, 210 right here. Give me a sec. There you go. And from here to here, I added 210. From here to here, I added 210. And from here to here, I added 210. So either way, I'm okay with. Now, what's important over here is that change in x was continually 1. And the corresponding change in y was always 210, right? So for example, what I'm saying is that when it did change 1, this was 210. When it changed 1, it was also 210, and so on and so forth, right? You know what? I just realized I just written that part twice. Silly me. Well, anyways, So that's basically what they're saying. For each change in x, the corresponding change in y was 210 every single time, right? In this particular case. Sometimes this number may differ, but we'll do that later on, okay? So now part E is asking, all linear functions behave similarly to the one in this example. Similar, the keyword is similar, okay? Not exactly the same. Based on this information, what generalization can we make from the constants that were given in terms of x and the y? Well, as you know, the slope is change in y and change in x. And in our case, every single time was 210. That's matched up with 1. So the slope is 210. And that right there, in this particular case, we're having a constant. The slope is constant. Okay. So linear equation. Another kind of inference that we can make is a linear equation or function, func, right, has a constant slope. Okay. Now it's possible that they may skip this value over here. Sorry, skip this value over here. So from here to here will be plus 2, and from here to here will be 420. But remember, in this particular change in y, change in x, it was 420, but its corresponding x was 2, which results in 210. So you don't always get a continuously increasing value for both x and y, but the ratio, right? The corresponding ratios should be the same, right? Every single time 210 if it is to be a linear function. Okie dokie. All right, guys, let's continue on. Forget this thing for a second. So any linear function can be represented by linear equation, and then linear function. So sorry, the linear equation is any equation that can be written in a standard form, as expressed below. So when you could write it as ax plus c, where a, b, and c are real numbers, and the keyword here is what? And a and b are not both zeros, right? So this form right here, that is known as a standard form. Okay. Any order pair that makes a linear equation true, so like, for example, the value, when you say linear pair, we're talking about the value of x and y, right? Remember, a, b, and c are just real numbers. It's just numbers. It's a coefficient. Sorry, a and b is called coefficient, and c is constant, right? So, given those information, as long as the x and y satisfy this equation, that ordered pair, because it satisfies it, it could be used to graph the picture. Okay, and the solution of the linear function. Sorry. So that is the solution of the linear equation in two variables. Okay. My apologies, guys. I'm just very close to my bedtime. The graph of the linear equation represents all the solutions of the equation. Because we are drawing a straight line, we only need like 2 or 3 points to know what it looks like. So every point, on that line represents the answer. Okay. Why don't we just do this out and see what happens? Okay. So there's a lot of talking over here. And let's make it a little more concrete by doing some examples. And per usual, whenever you're doing a problem, please read the question carefully. Look for the verbs, guys. Determine. What are we determining? That equation is linear. Okay. If so, right, graph the function by finding two here, x and y intercept. That's 2a and 2b, right? Plus at least another point. That's a c. Question is this a linear equation? And answer is yes. Why is it yes? Because it conforms to the standard form. So we could say that this is a standard form of linear equation. Okay? So how do we find x and y intercept? Well, x intercept is what? If you said it is a value of x such that the graph intersects the x-axis, then that is correct. But how do you find it? By setting y is equal to 0, right? So some people, when they do this, what they would do is literally 5x plus, replace the y with a 0, and solve for that, and x is 2. Well, that's very well nice. Okay, hold on a second. And then y-intercept is when x equal to 0. So that's point at which the value of y is such that the graph intersects the x-axis, y-axis. So, to find that, we set the y equal to 0. Sorry, x equal to 0. Sorry, give me a second. Oh, there you go. We got 5x equal to 0 plus y is 10. That's 0, so y is equal to 10. Okay, so that's all you do. So we look for, on the x-axis, we look for 2 right there, right? So that's x-axis. 2 is right here. This is the y-axis. We look for 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Right there. And what we're going to do, we're going to draw a straight line through that. Just like that. And let's move it into position slightly better. There you go. I think that's good enough. There you go. That's what it looks like. And then it's asking to find one other point. Okay. So what we can do is, okay, so what is between 0 and a 2? Right? Because I don't think I want to look for any points on this side because that line will go too high and it's not really realistic, right? So why don't we check when x equal to 1, right? So when you plug into the equation, 5 times 1 plus y is equal to 10, y equal to 5. So therefore, we should have a coordinate point 1 and 5. Do we? Let's check it out. We got x is 1 here, y is 1, 2, 3, 4, 5. Yep, it seems to cross that right there. 1, 5, 1, 2, 3, 4, 5. Yeah, that's correct. So now we have satisfied all 3 of them. You might have noticed, what is that little freaky little thing doing down there? Okay, just give me 1 second. Now, what's going to happen now is I'm going to show you a method. Okay, so we know that when we plug for y equal to 0, what happens? Right, the y disappears, right? So instead of plugging like this, what you can do is using the, what do you call this thing? Little tiny finger, your index finger, let's say, and you just cover up the y. What are you left with? We are left with 5x is equal to 10. When you solve for that, x must be 2. If you are feeling comfortable with the finger method, you may do so. Okay? How about this one right there? When you're looking for y-intercept, we want x to be 0, right? Using the finger method, you could just cover up this part, because when x goes to 0, 5 times 0 is equal to 0. It just disappears, right? And we could see that, literally, see that y is equal to 10, and therefore, this is 10 right here. Okay? All right, for the next one, let's use the finger method, shall we? First of all, is this a linear equation? And the answer is yes. Because it fits this, because it is a standard form. So you could put STD as in shorthand for standard, because that is a standard form of linear equation. All right, let's use the finger. So what is the y-intercept? When y is equal to 0. So we're going to cover up the y. When we cover up the y, what happens? We are left with Exactly. 4x equal to 11, which means what? X must be 11 over 4. You don't even have to say x equal to 11 over 4 because x in a set means x is equal to negative 11 over 4. Oh, it's negative. My bad. Right? And that is approximately, or negative 2.34. Sorry, negative 2 and 3/4. Right? And now using the finger method, what is a y-intercept? You get y-intercept when x equal to 0, right? So we put the finger right above x and the number in front of it, and we're left with y equal to 11. There you go. Okay, so now what do? We're going to, let's draw this picture, right? So that's 11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. That is 11 right there. And x-intercept is negative 2 and 3/4. Negative 2 and 3/4 right there. Oopsie. Negative 2 and 3/4 is right there. Okay. Now, if you want, it's okay to, even though after you answer the question, it's okay for you to use a different technique to confirm that your answer is correct. If you solve for y, in this case, it's 4x plus 11, and the slope is what? Change in y, change in x, is equal to 4 or 4 over 1, or simply negative 4 over negative 1. To find the points, what do? We go down 4, 1, 2, 3, 4, 1. 1, 2, 3, 4, 1. 1, 2, 3, 4, 1. And 1, 2, 3, 4, 1. Okay? And then you connect the two edge points. That way you get the best line possible. And here it is. Okay? So when you do that, it seems to confirm that this point sort of matches. Okay? Let me just actually, it was slightly off. There you go, right? So my estimation of negative 2 and 3/4 matches right there for the x-intercept. Now it is asking me for, hey, find at least one other point, right? So by us knowing that, knowing the slope, we found more points. So let's make this one. That's x equal to negative 2, right? So what we can do, hey, let's set x equal to negative 2. Plug into the equation. Negative 4 times negative 2 plus y is 11. That's 8 plus y is 11. Y should equal to, therefore, 3. So we should have negative 3, negative 2, negative 3 as one of the coordinate points. Negative 2, 1, 2, up 3, 1, 2, 3. Check. All right. So that is this one. Yay. We're done. Okie dokie. Okay. All right, guys. Let's move on. So, modeling with the linear functions, and we'll need to know that a discrete function is a function whose graph has unconnected points, right? It's this continuation from the previous material, right? So basically, when you say that, this is made of points. The graph is made of many points, or some people call this scatter plot. Okay. And then the second idea is that continuous function is a function whose graph is unbroken line or curve with no gaps or breaks. Okie dokie. All right. So we're going to do a couple of discrete function examples. Very, very similar to what we did before. Oopsie, the F is missing over here. My bad. Okay. And I have no idea why this is up here. Give me a second. I kind of did that ahead of time. Okay. So Sal, in example 1a, Let me zoom that just a little bit like this. Okay. Opens a new video store and pays the film studio $2 for each DVD. The amount the Sal pays is given by f of x equal to 2x, where x is the number of the DVDs. Okay. So that means this f of x represents money, and this is x, and that is the number of DVDs, right? Okay. So is this a discrete or continuous function? Clearly it's discrete. The domain is what? Well, you don't have to. It's possible that nobody bought a DVD, right? So it could be zero. It starts with zero. They could have bought one, two, dot, dot, dot. And there's no indication of his stock. So we're going to just assume infinity at this point, right? And then what's the range? Hence dot, dot, dot. Okay. Sorry for the clarification. Sorry. And that's the clarification right there. Okay, good. Then what is the range? Well, if it's $2 per, then what happens? If you buy nothing, you made nothing. If you sell one, there's $2 for each one. 2 times 1 is 2. And if you sell two, 2 times 2 is 4. You basically double everything, right? And then dot, dot, dot. Once you set a pattern, you could simply put dot, dot, dot. Okay, and we could just follow the pattern. And I kind of did this ahead of time. And basically, here are a bunch of points right there. Okay, let's look at that a little bit closely. All right, if it's 1, that's a 2. If it's a 2, 1, 2, 3, 4. Right, this is a 3, 1, 2, 3, 4, 5, 6. And 4 is 1, 2, 3, 4, 5, 6, 7, 8. Right, or what you could do is, you look at this, my slope m, changing y and changing x, is 2 over 1. So you go up 2, right 1, up 2, right 1. You could sort of see the pattern developing, right? And you could use that to draw the picture. These are slightly off. Should be here. That should be right there. That should be right there. And that should be right there. They're slightly off. There you go, fixed. Okie doke. All right. In part B, Elsa rents a booth in her grandfather's mall to open an ice cream shop stand, and she pays $1 to her grandfather for each hour of operation. So this is basically a rent based on time. And the amount of Elsa pays each hour is given by f of x equal to x. Because that 1 times x is still x, right? And x represents the number of hours her booth is open. Is this discrete or continuous? So is the value just continuous occurring, or is this something like it's like a counting, right? The keyword I think here was each hour that it is operating. So it is discrete. And the domain should be 0, similar to the previous one. 0, 1, 2, 3, dot, dot, dot. And for each hour, you pay $1, 2 hours for $2, so on and so forth. So the range will be exactly the same. And when you do that, I believe it should be kind of like this. Let's see if that matches. Yeah, it almost matches. There you go. That's slightly off. There you go. Okay. All right, guys. Hope that makes sense for you guys. So we got the last thing that we need to take care of. Here's a your turn. Why don't you pause the video, see what you could do. Okay, I'm going to assume that you have tried it on your own, and here are the answers. Okay, and that will be it for me. So, yeah, do me a huge favor. When you have any questions, come see me. Okay, all right, guys. Have a good night.